So today we are continuing on with parallel and perpendicular lines. Let's refresh our memories from yesterday. And parallel lines have equal slopes, same exact slopes. And perpendicular lines let's remember they form a right angle and their slopes are negative reciprocals. And two things to remember about negative reciprocals. The first thing, take the first slope, flip the fraction, and change the sign. If it's negative, make it positive. If it's positive, make it negative. So negative reciprocals just means you're negating the sign, which means you're changing the sign. So let's remember the slope formula. M equals y2 minus y1 over x2 minus x1. I'm going to call the first points x1, y1, and the second points x2, y2. So the slope of the top line would be 7 minus negative 2 over 0 minus 0. So minus a negative turns into plus a positive, and I have 9 over 0, and I know 0 on the bottom of a fraction means undefined. So that would be a vertical line. And it's a vertical line through x equals 0, just as an aside. All right, the other line, I see negative 5 minus negative 5 over 6 minus 3. Minus a negative turns into plus a positive, and I have 0 over 3. And I know 0 on the top of a fraction is equal to 0, and that is a horizontal line. And I know every vertical line and every horizontal line are perpendicular to each other from yesterday's lesson. All right, number 6, we have two lines. We have AB and CD. Let's find out if they're parallel, perpendicular, or neither. Let's check. I have 6 minus 7 over negative 2 minus negative 4. Remember, this is x1, y1. This is x2, y2. So 6 minus 7 is negative 1. 2 minus negative 4 turns into 2 plus 4, which is positive 2. And before I go any farther, I know if I'm looking for a parallel slope, it has to be negative 1/2. If I'm looking for a perpendicular slope, it has to be positive 2. So let's see what we get. The other line, CD, is 3 minus negative 2 over negative 8 minus 2. Remember, the minus sign is coming from the formula. The negative with the 2 is coming from the negative 2 up here. So minus a negative turns into plus a positive, and we have 5 over negative 8 minus 2 is negative 10. If I put that in my calculator and hit math, frac, enter. Math button, choice 1 is frac, and then enter, math, enter, enter is called math fracking. It will put any fraction into lowest terms for you. And that will tell me that is negative 1/2. So I have a negative 1/2, I have another negative 1/2. That means those two lines must be parallel to each other. Let's try a couple more. Let's go down here actually and start looking at equations and seeing if we can tell just from the equation if they're parallel, perpendicular, or neither. Remember, parallel lines have exactly the same slope, and the slope is attached to the x. So a 7 and a 7. Those are exactly the same, so these two lines must be parallel. Over here, we have positive 4/5 and negative 5/4. I flipped the fraction and changed the sign, so they have to be perpendicular. Number 11, remember you're just looking at what's attached to x. I have negative 1/3 and positive 1/3. Their signs changed, but the fraction did not flip. So this is a neither. These two lines would be neither parallel nor perpendicular to each other. Number 12, these are in standard form. I need to solve for y equals mx plus b form. In order to compare their slopes, I need to see this m right here attached to x. So I'm going to subtract x from both sides. And I have 6y equals negative x plus 30. I like to put the x term right after the equal sign, then the constant, and then divide by 6. Remember, there's an invisible 1 in front of the x. Divide by 6. Divide by 6. 6 over 6 cancel, and I have y equals negative 1/6 x plus 5. I really don't care about the plus 5 part. It's the negative 1/6 that I'm going to be looking at in a second. Over here, to get y by itself, I'm going to divide by 3, divide by 3, divide by 3, and the 3 over 3 cancel to 1, and I have y equals 6x minus 2. So negative 1/6 compared to positive 6, which looks like a fraction by putting it over 1. I flipped the fraction and I changed the sign, so these two lines must be perpendicular. Let's do a couple more. I want to get y by itself. I see the y is all by itself right now. It's a negative y. If I just add y to both sides, it's easy peasy to move that y over to the other side. It's just another way to do it, but you can keep following the same process we have been. And then to move the 4 to the other side, I would subtract 4 from both sides. Remember, your goal here is just to get y by itself. So 5x minus 4 equals y. If it bothers you to see the y on the right-hand side, you can use the symmetric property to move that y over to the left-hand side. So you just completely swap the two sides. And we're comparing negative 1/5 with positive 5. So that tells me I flipped the fraction and I changed the sign, so they are perpendicular. I want to skip the next one for now, and I want to do 15 and 16 before we run out of time. So right now, in front of x, I see an invisible 1. It's a positive 1. To make it look like a fraction, I would put a 1 underneath it and have 1 over 1. On the other side, I see a negative x. There's an invisible 1 in front of x. To make it look like a fraction, I would put it over 1. And if I flip the first fraction and change the sign, it becomes the slope of the second line. So therefore, flip the fraction, change the sign. These two lines are perpendicular to each other. So you had to see that there was an invisible 1 there in front of x. And we have number 16, y equals 6. Every y equals a number line is a horizontal line. And x equals negative 1 is a vertical line. Every x equals a number is a vertical line. And every horizontal line and every vertical line are always, always, always perpendicular to each other.